Good morning.
Good morning.
Morning.
Hello. Hopefully everybody's doing okay on a Thursday. We are going to look at questions 3 and 6, which those are the ones that I was thinking of going over, and then those are the ones that were listed on the question form. So we will look at number 3 and 6 from the worksheet. There's one other problem that I want to start with you, and that would be from the second review worksheet I have. And that review worksheet predominantly kind of goes through sections 2.5 through 2.7. So 2.5 was that fundamental theorem of algebra where we pretty much go through the whole process of finding the zeros using synthetic division, finding the imaginary zeros. And then 2.6 and 2.7 was the rational functions. But there's one problem in there that I want to start with you so that you kind of understand how to approach that type of problem. Test tomorrow, 65 points. It is 4 pages, but the only reason it's 4 pages is because one page has like 2 big graphing problems on it. And then there's like another big problem. So like they're all spaced out. So the problems kind of are just pretty spaced out. And the last page is like 2 questions. It's really half of the last page. So I try and keep it to a 3-page, like front, back, front, or 3 slides, since we're no longer on pages with actual paper. That's my goal of creating a test, to try and keep it to like a 3-page test. But depending on the spacing and how much space a problem takes up, it kind of flipped onto another slide or another page. It will take you all period. It took me about 10 minutes to complete. So I try and multiply that by 3, and the average student, it should take you 30 minutes, but like some of you, it might take a little longer. I'm asking that you do join Zoom tomorrow. You turn your cameras on to complete the test tomorrow. And that's pretty much moving forward, no matter what model we are in. I want to see your face as you're kind of working on the test. So I do ask that you have a second device. If you don't have a second device, I ask that you print out the test on paper and then have the Zoom camera running from your iPad. And if you have any questions or concerns about that, please send me an email. So we're going to go to the homework. As I said, numbers 3 and 6 are problems that I was going to go over anyway, but they were also asked about on the homework sheet. So we did number 2 together. And as I was looking at homework last night, number 1 looked great as well, having both of those problems right next to each other. They're the same type of problem. Looking up in the calculator, doing synthetic division, and then finding the solution either by factoring, using the quadratic formula, or in this case for number 2, we just were able to solve that remaining expression. So number 3 says, given the polynomial f of x, write f of x as a product of linear factors. And that really just means factor completely. So if you see those words, it means we want to just break down the problem entirely. So I want to be able to factor it completely, break it down in its entirety. Before you think about using synthetic division and looking zeros up in the calculator, remember when you look zeros up in the calculator, they need to be rational zeros, which means they have to be in the values of P and Q. If you just look at the problem and look at the pattern of the problem, and that's the key. So thinking about what form is the problem written in, is there a pattern as to the way the problem is written? So if I compare number 3 to 1 and 2, number 1 has the x to the 4th, x cubed, the x, the 24. Number 2 has x to the 5th, the x to the 4th, the x, and the 2. They both have 4 terms. Number 3 has 3 terms. And when an equation has 3 terms, what method can we use to find zeros or factors when there are 3 terms in an equation?
AC grouping.
Yeah, thanks, Jenny. So we can use AC grouping. This is in that form. Generally, we talk about it as ax squared plus bx plus c. That's that trinomial pattern. So there's 3 terms in that quadratic pattern. The only difference is that this is x to the 4th, but it's still in that trinomial pattern. And when it's like that, we can use the traditional AC grouping. And I think that once you learn new concepts in math, you feel like you have to use those new concepts and you forget about the factoring. And like that factoring that's like the standard way of solving an equation. That's the first thing we want to think about. And it kind of gets pushed in the back of your mind and sometimes becomes the last thing that you want to think about. So we're going to factor this one with regular old AC grouping factoring. So Jenny, we have the value of negative 28. What two numbers combine together to be negative 28?
-7 and +4.
Yeah, we're trying to get a -3 in the middle there, and -7 and +4 work. So if we're using regular old factoring here, we would have x to the 4th, -7x² plus 4x². So that would be the difference. Those two middle terms are x² because we get a -3x², and then -28. And then grouping, pulling the terms together, those first pair have an x². The second pair have a 4. Sorry, I'm trying to be quick here and I'm getting sloppy. And then if we pull those pairs together with the grouping, I can now group x² and +4 together because they're like terms, they're both being multiplied by x² plus 7. Remember, this little plus sign is so important. In math, one step must be equivalent to the previous step. If you don't have that plus sign there, then my second step is not equivalent to the first because then it becomes entirely multiplication. And if I multiplied everything together, I wouldn't go back to that first step. So that plus sign is still showing that I'm grouping binomials together. So that plus sign is just this plus sign here being carried down. Once you group them, then taking the two common terms and pulling them in a parenthesis and the x² minus 7 and pulling it in a parenthesis, that's when I can make it multiplication because now I'm pulling the pieces together and making it multiplication. All right, so this is factored using the AC grouping. The question wants you to write it as a product of linear factors, which means I have to completely factor the problem. Linear means that these terms, these should be just x, and right now we have x². So Peter, how could I take those two factors and try and break them down further so that I can find all of the factors to this problem?
You'd set each of the parentheses equal to 0.
Yeah. So set them equal to 0. And then, Peter, what values do you get when you solve for them?
You get x is equal to plus or minus 2i, and then x is equal to plus or minus square root of 7.
Excellent. So if you did look this up in the calculator, you would have found two x-intercepts, one at -√7 and one at +√7, which is a decimal. And you probably got a crazy decimal and then weren't really sure what that crazy decimal represented. And when you have a decimal like that, you can't use synthetic division. So synthetic division must be used when you have rational numbers. So we are going to take those two sets of zeros that Peter gave us, and we're just going to place them in factored form. So completely factoring it, taking these two quadratic factors because they said x², solving them both, and then taking my zeros and writing them as factored form. So 1 0 would be a -√7, and then we would have a +√7. They should go in the front because those are the real zeros. And then behind that, we have the -2i and the +2i. So this would be a completely factored answer, Make sure you have it equal to f of x. You don't want to lose a point because you're not properly notating your answers. So make sure you have f of x there because it was a function. It started out with f of x. It needs to end with f of x when we have it a product of linear factors. If it said list the zeros, we have those zeros listed as well because we use the zeros to actually create the factors. Does anybody have questions on number 3? So don't always just think I have to use synthetic division. This is like the old school method, factoring. Still works. So questions on number 3. Looking at number 4, I'm not going to go over number 4, but number 4, this is another trinomial, 3 terms, and this is also like regular old factoring. So A says find the x-intercepts algebraically. Pull out a GCF. It has a GCF. Pull that GCF out and then factor it. So you're going to set it equal to 0, pull a GCF out, regular old factoring for that problem. Part C and D, finding the max and mins, that's the way you use the calculator. And then describing the end behavior as x goes to infinity, y does this. As x goes to negative infinity, y does this pattern. So that would be that end behavior. And then graphing it. And you will be given a problem just like that. So it'll look very similar for you to kind of work through. I would say this review worksheet is very close to looking like your test tomorrow. Number 6 was the other one that I saw, and I think 6 is tricky because of the imaginary number that's given. It's a complex 0. So find a polynomial function with it says with integer coefficients. That just means the numbers in front of our x terms when we FOIL it should all just be integer numbers. So a 1, a -1, a 5, a -5. We shouldn't have any fractions in the problem. And it does say that our zeros are at 1 plus I root 3. This 0 is together. You cannot separate it. That's a complex 0. So it has to stay together as a complex 0. I can't separate the 1 from the I root 3. So they are together. And then we have 2 zeros at the value of 2. So that would be a double root. Darby, how could I take a 0 and write it as a factor?
So you would do x minus 2 squared since it's a double root. And then you would do x minus 1 plus the I square root of 3. And then x minus 1 minus I square root of 3.
Where'd you get that other 0 from?
It has to be, since I plus 1 to the square root of 3 has to be a conjugate, so they can cancel out.
Excellent. So if you have one imaginary 0, you will also have a second imaginary 0. As she said, they are conjugates. They always occur together as pairs. So if I have 1 plus I root 3, I also have 1 minus I root 3. So they will always occur together in pairs. So when we go to FOIL these, we are going to group the first 2 terms together, that x minus 1 and x minus 1. Think of them as a pair, x minus 1. They're both real, x is real, -1 is real. And when we FOIL, we are foiling this pair together. So I'm taking x minus 1 times x minus 1. So if I multiply x minus 1 times x minus 1 together, I get x squared minus 2x plus 1. But I'm not done with that because there are a lot of things being multiplied here. And when I FOIL, my inner and outer terms cancel because of conjugates, but then my last terms are still there. And my last terms will be -I squared, and then I have a square root of 3 and a square root of 3, which makes the square root of 9. But this all has to stay together. So this is all together. And the reason it's together is because they're zeros together. Again, the x minus 1 isn't separate. It is together with the I root 3. So we know that an I squared is really a -1. I also know the square root of 9 is 3. So I have x squared minus 2x plus 1, and then this last term is really plus 3. But again, they must stay together. So many students are trying to separate it, and that is found from an original equation that I would have to use the quadratic formula for. So I can't separate them because they were created from their own separate equation. So this is x squared minus 2x and then plus 4. So if I use the quadratic formula and I solve for x, that's how I would get those zeros. That's where they came from, just like you did with number 1. Number 1, you had to solve using the quadratic formula and you found imaginary zeros. So the imaginary zeros that you're finding from the quadratic formula, those complex zeros, look like this form. So that's where they're coming from. They're coming from one equation together. The other equation we have here, we have that x minus 2 quantity squared. So that would be x squared minus 4x, and then it's still plus 4. So I have my real zeros that created an equation, and I have my imaginary zeros that created an equation. And they both created quadratic equations because there were 2 zeros for each of them, 2 real, 2 imaginary. So Cole, what would we do now that I have these 2 sets of quantities? What do we do with these 2 sets of quantities, Cole, to find a polynomial function?
Would you distribute each part into the other parenthesis?
Excellent. And he used the perfect word, that distribute, because that's what you're really doing. You're taking each part in the front and you're distributing it to each part in the back, or each piece of the back. Just be really careful watching all of those powers. So x squared with negative 2x, and then x squared with 4. And then you're going to take the negative 4x through, being really careful with your signs and powers. And then finally, I'm going to take that last 4 and distribute it through as well. So you should have a really large expression because you're multiplying 3 terms with another 3 terms. And that's why you get a large expression there. 3 terms by 3 terms is 9 terms. Again, don't forget that notation. Make sure you're writing it as f of x. Don't want to lose silly points for notation. And then combining the like terms. I know it's a lot to look at. So we have a negative 6x cubed. And then looking at those x squared terms, here's 4, 8, 4 more. That makes 16. And then the just x terms, that looks like negative 24. And then plus 16 at the end. Does anyone have questions on that? So when you see a complex zero, don't separate them. So you need to just do all the multiplying first. And I would like worry about the complex zero first. So do everything you can with that complex zero. Foil the pair of first terms, foil the imaginary terms, and then add those values together, add those pieces together. There's a lot of foiling involved. Another problem that probably is worth like 6 points. That's an involved problem there. Questions? So as I said, I wanted to go over a problem on the second review worksheet that's in your packet. If you do have other questions that you were hesitant to ask, you can feel free to remain on and I will answer any questions that you still have. Like it's a question and answer day today. But what I would like you to find is page 57. Page 57 is just a review worksheet for sections 2.5 through 2.7. And there are just 5 questions on here. The first 3 questions are dealing with the rational functions, finding the intercepts, the asymptotes, the domain, the range, all the questions we've been working on. So this is posted on Google Classroom. This is also in that same chapter 2 packet. So if you are just using this chapter 2 packet because you have all of it in Notability, you can just scroll down or up to page 57. Or you can go to the assignment in Google Classroom and find the assignment there. The solutions are also included in the assignment on Google Classroom, and they're included at the bottom of the page. So again, 1, 2, and 3 are analyzing the function, the rational function. Number 4 says factor the polynomial into linear factors. So when it says that, that means you need to take P over Q. You need to find the zeros in the calculator. And then you need to use synthetic division. So if you see those words and it is a really long problem, every exponent is represented. That's the process of finding the linear factors. If it was a short trinomial and it said to factor completely, then you can just use AC grouping. But if it has 4 terms, 5 terms, 6 terms, that's the big process. P over Q, find the zeros from the calculator, use synthetic division. I want to go over number 5 because we haven't done one of these problems in a little while. And this is one of those really good problems that kind of lets me assess a couple of different concepts to see what you remember, and if you know multiple concepts in one problem. So this says find exactly all of the zeros of the polynomial, but then the wording of this is a little different, given that x plus 1 is a 0. So they're giving you a complex 0. They're saying this is a 0 from the equation, from the function. We want to find all of the other zeros using the fact that 1 plus I is a 0. Does anybody remember how to approach this problem? So if they give you a complex 0, how do we use that complex 0 to approach this problem, to solve this problem?
Would you start by using it? Well, I forget the word for it, but it would be like 1 minus I.
Yes,
For another
exactly.
zero.
Yep. So Peter said we're going to start by thinking about that it has also a 0 at 1 minus I. Those are our conjugates. They always occur together in pairs. Peter, what do you think you would do with those pair of zeros? What would we do with them?
Would you multiply them by each other?
Yeah, we're going to
Or it would be, would it be x, like, would you multiply the x minus quantity 1 minus I and then
Yes.
x minus?
Yep.
Okay.
Yep, you're exactly right. He's making them into factors. So the first thing we're going to do is take those 2 zeros, just like we did above. We're going to make them into factors. Because our goal is to create or find the equation that created these zeros. And remember, a 0 as a factor has to have that x. So this is the same type of problem that we just went over, grouping the x and the minus 1 together. So this is good that we get to FOIL another one of these together. So x minus 1 times x minus 1 is x squared minus 2x plus 1. My outer term and my inner term cancel. That is a property of conjugates. Every time you multiply by conjugates, the outer and inner terms cancel. And then my last term would be a negative I and a positive I, which is a negative I squared. So the equation that would be created from the 2 complex zeros is x squared minus 2x, and then negative I squared. Well, I squared is negative 1. So when I have a negative negative 1, that makes a positive 1, plus the positive 1 I already have means I have a plus 2. So here is the equation that we would have used to find those imaginary zeros. With the quadratic formula, or completing the square. That's another option. You can complete the square. That works too. Okay, so now that I have this equation, what do we do with this equation so that we can find real zeros, because we have two imaginary zeros. We need two other zeros, and they're probably going to be real zeros. But how do we use this equation to find those two real zeros?
Would you have to do long division?
Yeah, nice job, Peter. So this is why I like this kind of problem, because it shows me that you can multiply, that you understand zeros occur together in conjugate pairs, but then it gets you to do some long division. So you're going to take that equation and we're going to use long division, and we cannot use synthetic division because it's not of the binomial form. It doesn't just say x plus 2, x minus 2, x plus 3. That's why we have to use the long division. And we're looking at that original function with all of those powers. And make sure you're writing all the powers. X to the fourth, negative 2x cubed, missing an x squared, and then there's a plus 4x, and then the minus 4. Don't forget that x squared term so that we have a place for all of our powers. So when you use long division, you're only worried about the first term. We eliminate one term at a time. Caden, what do I multiply x squared by to make it x to the fourth?
X squared.
Yeah. I'm going to place that on top of my x squared term. I'm multiplying that x squared by all of that divisor. So I have x to the fourth minus 2x cubed plus 2x squared. And then remember, that's a big minus sign in front. That means my second term is now a plus. My third term is now a minus. X squared minus, or x to the fourth minus x to the fourth cancels. Negative 2x cubed plus 2x cubed cancels. And then we are left with 0x squared minus 2x squared. So I'm left with a negative 2x squared. I'm going to bring down the 4x. I'm also going to bring down the negative 4 because two terms canceled out. So I need to bring down two more terms. Plus, I have a trinomial here, so I need to divide it with a trinomial. Caden, we have an x squared. We need to multiply it by something to make it negative 2x squared. So that would be?
Negative 2.
Yeah. And again, we're subtracting. So this is now a minus sign, this is a plus sign, this is a plus sign, and we better get a remainder of 0 because our goal was to find the zeros. So whatever is left up here is going to give me my remaining zeros. If you just set that equal to 0 and solve, you will find the other remaining zeros. So x squared is equal to 2. If I take the square root, don't forget it's plus or minus because we took the square root. I then have found the other remaining zeros. So 2 zeros are real, 2 zeros are imaginary. So 2 of them were given to us. One was implied that it's there because you have to have one with the other for them to be complex zeros. So another question there, great problem. As I said, like maybe 6 points for that problem too, because it's asking you to do a lot of stuff. So you can kind of see like you could have 6 or 7 problems on the test, but all of them are worth a lot of points. So test tomorrow, chapter 2. If you're taking the retest, you should have had an email from me with a link for Zoom. Some of you are still taking it yet today. It's actually a good way to prepare for tomorrow's test because a lot of those concepts are kind of in the concepts we've been working with. If you have any questions, you can feel free to remain on. You have just 4 questions to review. If you have any questions tonight that you run into, please email me. I will open a Zoom link for you tonight or tomorrow morning from 7 to 7:20 if you want to come on. I can have a Zoom link prepared for you and I'll attach that in a Google Classroom for you. Have a fantastic day. You don't have to remain with me. You still have 10 minutes. But again, if you want to, if you have questions, feel free to stay on and I'll answer any other questions that you have. But otherwise, have a great day.
Thank you. Have a good day.
Bye,
Have
Miss
a good
Kane.
day.
See you later.